Have you ever experienced tearing directly at the preparation margin when removing an impression from the mouth? Not only is this annoying, it is also expensive, time-consuming and inconvenient for the patient. At Heraeus Culser, our dental silicone research department puts considerable effort into preventing material from tearing as far as possible. Join us as Dr. Grundler explains what needs to be taken into consideration.
Hello, Ms. Lyer. Welcome to our laboratory.
Thank you.
Pleasure.
Mr. Grundler, what influences is an impression material subjected to when it's removed from the mouth?
From a physical point of view, considerable compressive and tensile stress are exerted on an impression material when the tray is removed. Due to suction, a precise impression adheres tightly to the hard and soft tissue in the mouth. Undercuts, narrow proximal spaces, and deep tapered sulcus areas make the removal of the impression even more difficult.
What are the most important physical characteristics in this regard?
There are three main parameters: the tensile strength, commonly known as tear strength, the elongation at break, and the toughness. Simply put, tear strength depends on the maximum tensile force required in order to tear the material. An impression obviously should not tear as soon as a limited amount of force is applied. This is why a high level of tensile strength is required. However, merely viewing this parameter in isolation is not sufficient.
What else must be taken into consideration?
The tensile strength only tells us how much force is required to tear a sample of the material. However, it does not tell us anything about the material behavior before the breakage occurs. Consider undercuts on a tooth, the interdental spaces, or the sulcus region. So a dentist can remove the impression material must stretch and then return elastically to its original shape. A sparsely ductile material like impression plaster is hardly likely to lend itself to removal without breaking.
And which parameter tells us more about the required elastic properties of the material?
That would be elongation at break. In other words, how much a material has stretched before it actually tears. For an optimum impression material, an even balance is required between tensile strength and elongation at break. This allows the material to be easily removed and prevents thin flags of material from tearing.
It's starting to get complicated. Is there a single parameter that combines tear strength and elongation at break?
Yes, there is indeed such a parameter. It is known as toughness and is the technical parameter that combines both characteristics. Simply put, the toughness describes the amount of energy a material can absorb before it tears.
And how can the toughness of a material be measured?
The toughness cannot be measured directly. It is calculated technically from the elongation at break and the tear strength. For the testing, a standardized impression material specimen is secured in a tensile testing machine. With a defined speed, the machine pulls the specimen apart until it tears. The elongation of the specimen and the respectively required force are continuously recorded in what is known as a strength elongation curve. The area under the curve represents the energy a material can absorb before it tears. It is known as tear energy. Related to the volume unit, that is the toughness of the material.
And how does Flexitime behave in this test?
In this regard, I would like to show you exemplary measurement results from an independent testing institute. The study compared the toughness of a polyether with that of 5 different A silicones. Thereby, significant differences between the materials were detected. Compared with the A silicones and the polyether tested, Flexitime medium flow showed the highest toughness in this test.
This means using a material with high toughness can prevent tearing of material flashes and thus avoid repeated impression taking. Thanks to its high toughness, Flexitime can thus save time for the dentist as well as preventing stress for the patient. Thank you for this insight into your research department.